Okay, college algebra. Time to get a move on. We're doing 4.2. I actually removed all of the financial and word problems from the homework because they really require a calculator, and you're going to get a calculator on the final anyway, so there's no real point in doing them. They're more appropriate for other classes. We do need to talk about some parts of this chapter, though. Rational exponents. So when you say something like 4 to the 3/2 power, the numerator of the power is what you're raising it to, and the denominator power is the root. So a second root really means the square root, and then you'll take the square root of the number and raise it to the third power. Now, you always put the negative number with the numerator, and we'll talk about what negatives do. So when you see 4 to the 3/2, it's really the square root of 4 to the third. We should know what the square root of 4 is. It's 2. And 2 cubed is 8. It is always, always, always easier to get smaller than bigger. You could do 4 cubed in this, or 4 to the third power, which is 64, and then to take the square root and get 8. But you may end up in some not so nice situations. What if it was 8 to the 17/3? That's not super friendly to raise 8 to the 17th power. So it's easier to get smaller before you get bigger. So 27 to the 1/3 really is the cubed root of 27 to the first power. Oh, we don't care about the first power, but what is the cubed root of 27? It's 3. Anything to the first power is itself. It's not too bad. Okay, 64 to the -3/2. So again, this is the square root of 64 to the -3rd. To reiterate, the negative always goes on the outside with the numerator power. The square root of 64 is 8. Now, how do we deal with negative powers? So when we're trying to do 8 to the -3rd, that is the same as 1 over 8 to the +3rd. It doesn't make it negative, it turns it into a fraction, 1 divided by. So 1 divided by 8 cubed is 512, so this is 1 over 512. So these are all important things to know when you're doing your homework. Now, on page 2, it talks about there are 4 options for graphing. However, there are only really 2 options for graphing, because the first and fourth option on that page are the same. The second and third option on that page are also the same. So they actually graph exactly the same as each other. So we'll go in depth with the first one, 2 to the x. Let's make an xy table for 2 to the x. 2 to the 0th power is 1. We can plot that. 0, 1. 2 to the first power is itself 2. 2 squared is 4. 2 cubed is 8. So let's plot some of these. So on the right side of this graph, it kind of looks like it's doing something similar to a parabola. What about on the left side? What about if we do negative numbers? What's 2 to the negative first? We just talked, what does a negative power do up in the previous problem? It turns it into a fraction, so it becomes 1 over 2. 2 to the negative second becomes 1 over 4. 2 to the negative third becomes 1 over 8. These are all getting closer and closer to 0. So we've got half, a fourth, an eighth. It's really actually flattening out. Just turn them into fractions, and it flattens out. So on the right side, yes, it looks like a parabola, but on the left side, it kind of looks like it's approaching an asymptote like a rational function did. So it's kind of like a half and half. Now, the only thing that's going to change for the other side, and this also works for 1/2 to the negative x, which is the fourth graph, or fourth area. So what happens if we're doing 1/2 instead? And this has to do with multiplying by a fraction. Remember that an exponent just means repeated multiplication. So what does repeated multiplication actually do? If you take a number and you multiply it by a half, does it get bigger or smaller? It gets smaller. So as you go to the right, we'll see what happens. So let's make a chart for x and y for the right graph. 1/2 to the 0 power, anything to the 0 power is still 1. So we're still at that same starting point that we were going the other direction. But 1/2 to the first power is now 1/2. So 1/1/2 is actually going down. 1/2 squared is 1/4. 1/2 cubed is 1/8. So instead of flattening on the left side, it's now flattening on the right side. So this one was half, looks like it was approaching an asymptote, half like a quadratic. This one is going to be the same. Half looks like it's approaching the asymptote, only it's the opposite side. The other half ends up behaving 1/2 to the -1 is 2, to the -2 is 4, to the -3 is 8. So over here we've got our half that looks like a parabola. So, moral of the story, your graphs for rationals are only going to look one of two ways. With the exception, you can put like a negative number, and like if a negative's in front of 2 to the x, you can flip it downward. But it's only going to look one of two ways. It'll look like it's approaching an asymptote on one side, and it'll look like it's behaving like a parabola on the other side. And that's it for this half, and we'll do some more examples in the second set of notes.